So this will be my first time using this program, so we'll see how this goes. But remember, we're doing glycolysis. Oh, I spell so well. Okay, I'll learn to type that before. But what glycolysis is, if you remember, is the splitting, lysis, of glycose sugar. So splitting of sugar to gain energy. Some key words I want you guys to remember as we go through this are going to be reduction and oxidation and phosphorylation. So remember, oil rig, oxidation is loss, rig, reduction is gain. So if it gains an electron and a hydrogen, we're going to call it reduced. And if it's going to lose that energy, we call it oxidized. I'm going to break everything down, and we're going to talk about it in terms of carbons because everything's an organic molecule. So each little C is going to represent a carbon. Now, do you know that in sugar, carbon's also going to have an oxygen and 2 hydrogens attached to it because it has a water, but it would take us a long time to draw those. So number one, this occurs in the cytoplasm. So maybe there's a mitochondria down here, okay, and we're out here in the cytoplasm, okay? And we are going to start with a 6-carbon sugar. Okay, I'm showing the bonds between it. We need 1 more carbon here. Okay, we start with a 6-carbon sugar. We're in the cytoplasm, and the first thing that's going to happen is the energy investment stage. So I'm going to show a little arrow coming down here, and we're going to have our 6-carbon sugar again. I am really, really bad at drawing these carbon sugars, but hopefully it helps. And what we're going to do is we're going to take an ATP and we're going to invest 2 of them. Okay, and that's going to be phosphorylated to form ADP, adenine diphosphate. The good news is this is nice and slow for you guys to follow. And we're going to do that twice. And what's going to happen is we're going to add 2 phosphates to this. I wish I could change the color on this. We'll do a thicker line. Okay, so we're going to add 2 phosphates. Okay, so we have now gone from glucose. We have invested 2 ATP to form a bifructose molecule. So that's a fructose molecule with 2 phosphates on it. It is now even more energized than it was before. The next step is going to be to split this molecule into 2 pieces, and we're going to form 2 G3Ps. So in this stage, we now get a 3-carbon molecule. And I'm going to go back in and put the name of this on here in a minute. We get a 2-carbon molecule and keeps its phosphate. Nothing's happened to that. Okay, so we got our 2-carbon molecule. I'm going to circle the phosphates because I think that's important. And as this happens, we're going to actually have an inorganic phosphates that are just floating around. And this PI stands for inorganic phosphates. These are just floating around out in your cells, and 2 of these are going to come in to the equation here, and they're going to be put on the other side of this. So both of these molecules now have 2 phosphates, and this is called G3P. Glycerol triphosphate, and it's a 3-carbon molecule. We'll put that right here. Oh, don't know what happened there. Okay, so this is called G3P, and both of these molecules are now G3P. Okay, at the same time, one of our electron carriers, NAD, is going to be reduced, and it's going to oxidize this molecule up here. So NAD comes in, it is reduced, but the by fructose up here, this 6-carbon molecule is oxidized. So we're actually oxidizing the sugar, and we get something called NADH. Okay, so NADH is reduced, and this is oxidized. So we've now added electrons to this, and this happens for each molecule, so we get 2 NADHs. Okay, now we have formed our G3P, and remember each step, there's enzymes doing this. At this point, we would have had about 8 enzymes to get us this far. We don't have to worry about all of those. And we have one less step left, and that step is to form our final product, which is just going to be a 3-carbon molecule called pyruvate. Okay, so we've now formed these 2 molecules called pyruvates, and at this time, we need to harvest these phosphates off the G3P, and that is going to be done using a kinase. And so an ADP is going to come in for each molecule, and it is going to be phosphorylated. Remember substrate phosphorylation to form an ATP. And this, just like this one up here, happens in both places. So I'm just going to put a 2 here. I could draw it again on this side, but it's kind of hard to draw on a computer screen. So at this point, we now have formed a total of 2 ATP here, and we're going to form 2 ATP on this side. Okay, so 2 ADP are going to come in, and they're going to take both these phosphates, and we are left with 2 ATP. Okay, and this molecule down here is known as pyruvate, and I am going to type that because I can. Okay, so we get pyruvate there. We also get pyruvate here. So this is glycolysis. I recommend drawing this yourself. Practice a couple times and go through the steps because it's really going to help you understand what happens in glycolysis. As we do that, I'm going to continue to add text to the side to kind of guide you on how to talk about this. So what happens at this step is glucose is phosphorylated by 2 ATP, forming a 6-carbon biphosphate. You want to get fancy, you can know that it's fructose biphosphate. I don't care if you guys go that far on it. That is what happens in the first part. That's our investment stage, okay? So this is the investment. Okay, our next stage is over here. Fructose biphosphate is oxidized by NAD, or NAD is reduced to NADH. Okay, that's our step right there to form And then we get our GDP forms, and then this step over here, okay, is going to be our harvesting of the energy. So G3P is phosphorylated to make 4 ATP and 2 pyruvate. So if you were to put this all into an answer, if it was longhand, you could start by saying glycolysis occurs in the cytoplasm. In the investment stage, glucose is phosphorylated by 2 ATP, forming a 6-carbon biphosphate. That biphosphate in the lysis stage is oxidized and forms a reduction of 2 NADHs. No idea how to get rid of that thing. Okay, forms 2 NADHs, and then in our harvesting stage, G3P is phosphorylated to make 4 ATP and 2 pyruvate. In the end, your total ending is what do you end up with? You can go back and count. We have 4 ATP, net 2 ATP, because 2 of them were put in up here. So overall, our cell ends up with 2 ATP, 2 NADHs carrying a nice hydrogen and electron for the electron transport chain, and 2 pyruvate. That is glycolysis. I hope that helps. I'm sorry if it was a little slow. I'm used to doing this on a text on the whiteboard. It's a lot harder on a computer with a mouse. I'm going to get a lot better at it, I promise. If you guys have questions still, please reach out to me during office hours. Next, we will do the link reaction and the Krebs cycle.